Okay, so problem number 5, it said pick any test and explain why it works. I'm going to do two. I'm going to do the direct comparison test, and then I'm going to do the integral test. And they're kind of similar. So what this says that if let AK be less than BK, and it says 1 that if sum AK k equals 1 to infinity diverges, so does this series. And it says that if k equal 1 to infinity bk converges, so does ak. So I'll do 1, and I'm going to say that if AK1 diverges, it diverges to infinity because all the terms are positive. If AK is less than BK, then just by the rules of addition, this series AK has to be less than k equals 1 to infinity bk. So if this is equal to infinity, then this has to equal infinity too. Okay. If the smaller series is infinite, so is the bigger one. And it's the opposite here. If this diverges, if BK converges and AK is less than BK, less than 0, then the series AK is going to be greater than 0 because you're adding positive terms, but that's going to be less than this, which converges equals some number L, so therefore k equals 1 to infinity, AK converges. In other words, if the bigger series converges, so does the smaller series. Okay, that's all that is. Okay. Now I'm going to also do the integral test because some of you tried to do that. And the key to the integral test is these two pictures. Basically, the integral test says that AB integral f of x d of x converges, diverges, if and only if the associated infinite series does the same thing. And that AK is just that function f evaluated at integral points. So this means that this series converges or diverges if and only if these do. In other words, both series do the same thing. So there's two pictures. Here's my function. And if you draw the series one way, you see that f of x is less than the series starting at 1. And if you see that f of x is greater, if you draw it this way, f of x is greater than the series starting at 2. But if the series starting at 2 diverges, so does the series starting at 1. Adding the first term isn't going to change anything. And if this series converges, then this series will as well. Okay, so basically, here's what you say. So if this series diverges, then this is going to be less than the series starting at 1. I'm going to call this picture star by star. Therefore, we have infinity less than or equal to this series. So therefore, this series AK diverges to infinity. Okay, so that's this part. Now we'll do this part over here. I'm going to do it down here again. So if my integral converges, this is going to be asterisk. Then by asterisk, this integral f of x is going to be greater than the series starting at 2. So, well, that means that this is less than infinity. This converges. That means this series is also going to converge. The convergent integral is bigger than the convergent series, and therefore adding a1 to the series starting at 2 won't change anything. So therefore, sorry, I'm being kind of sloppy over here. Therefore, this series AK converges as well. Again, what's going on is that we start with the integral. If we know that it diverges, then we look at this picture, and that tells us that the series diverges because the series is bigger than the integral. And if our integral converges, then we look at this picture because that tells us that the series starting at 2 is less than the convergent integral. And adding a1 to the series starting at 2 won't change anything about convergence or divergence, so therefore that series converges.